Okay, welcome back to our statistics class notes. We're at the top of page 96 now. We're in section 7.2. All right, what we're getting into at this point is I'm going to go through a series of 3 simulations that I've conducted, and they're basically to try to show you, how we're going to arrive to the amazing conclusion that we're going to arrive to with what's called the central limit theorem in the next section. So I'm now going to start with simulation 1 here, which is example 129. We're trying to understand the behavior of estimators here. So I want you to assume that we have a small population of 8 people. So we're only talking about a population that consists of 8 people. They're participating in a 5K run, 5-kilometer run, 2 of whom are walkers and 6 of whom are runners. So we know that of the 8 people in the population, 2 are walkers, we'll label them W's, and 6 are runners, R. So I'm going to take random samples of 4 people from this population of 8, and then I'm going to compute the percentage of walkers that I get in each sample. Now what I want you to remember here throughout all of this is that P, the population percentage of walkers, is 25%. Okay, because there's 2 out of my population of 8. There's 25% of my population of 8 people are walkers. Now, will each sample I collect get exactly 25% walkers? 1 out of 4, right? I'm going to do 4 samples of size 4. Is it possible to get a sample with no walkers? Yeah, certainly, right? It's certainly possible to get a sample with no walkers, right? If I select 4 people out of the 8, I could get 4 that are all runners, right? So I certainly could get a sample with no walkers. All right, now let's construct random samples. I'm doing this with StatCrunch. Similar to prior simulation I've done. I'm not showing you how I'm doing it, but I just want to write some results down. Let's assume the following 3 random samples were taken. So my first sample, I got a walker and 3 runners. So P hat from this sample, I got 1 out of 4 walkers, so it's 25% also, which is actually P, the population proportion. So that time I got 25%. The next sample, I get 4 runners. So P hat was 0. I got no walkers in here, so I got 0% walkers. And in another sample, I got 2 walkers out of my 4 that I sampled. So the P hat gave to 50%. Now really notice I can't get anything else, right? I can either get no walkers, 1 walker, or 2 walkers in my sample of size 4. Now I could do a bunch of samples and I would always get those. The sample proportion P hat changes from sample to sample, right? So every time I do a sample, now what I'm getting you to think about is this is eventually going to be, I'm going to do a survey of 100 people, 1,000 people, whatever it is, and I'm going to construct a P hat. And notice that if I did another set of surveys of 100 or 1,000 people, I should get another P hat. It's going to change from sample to sample. But the population proportion P is the same. It's 25%. It's whatever is true in the population. Whatever is true in the population. Okay, so first sample I got 25% walkers, which actually was equal to my population proportion of 25% walkers. In the second sample, hey, the population proportion doesn't change, but that time I got 0% walkers in my sample. And in the third time I sampled, population proportion stayed the same. It doesn't change because that's the truth of the population. But my sample, I got 50% walkers. Now, the sampling distribution of P hat is what I'm trying to get you to understand how this will work as we go along. That's the probability distribution of P hat. That's called the sampling distribution. We can represent it using a table or a graph. So if I were to do a whole bunch of samples of size 4, eventually over time I would get a probability of seeing 0% walkers to be about 21%. The probability of seeing 25% walkers in my sample when I know the population proportion is always 25% for these. I would get that 57% of the time, so certainly much more than the other 2. And I would get 21% of the time I would get 50%. You don't need to worry about how I computed these probabilities, please. That's actually from section 6.3, which we didn't cover, so don't worry about that. Now remember, P hat represents the sample proportion, and P represents the population proportion.